So in this video, we're going to solve a problem from exercise 7.3, which belongs to chapter number 7, triangles. It's question number 4. So let's see what the question is. BE and CF are two equal altitudes of triangle ABC. So the diagram is not given to us, so we have to construct our own diagram. So I'm going to draw triangle ABC. Let's come down here. So this is my triangle ABC. Okay, let's name the sides. This is A, this is B, and this is C. Now, what the triangle reads is, what the question reads is BE and CF are two equal altitudes of the triangle ABC. So we have to understand what is this term altitude. So let's try to get rid of this. Yes, this is the definition of altitude that I have mentioned here. I'm just going to mark an arrow. So let's read it out. It's a perpendicular drawn from the vertex to the opposite side. Okay. So BE is a perpendicular drawn from the vertex B to the opposite side. Quite simple. So I'm going to draw a perpendicular from BE to the opposite side AC. Similarly, we have CF. So a perpendicular drawn from from the vertex C to the opposite side of the triangle. Okay. So once again, let's draw it. So this is going to be something like this. Oh, sorry. So let's use a straight line. So something like this. Okay. And the key thing is it's perpendicular. Okay. Altitude is perpendicular. So I'm going to mark the perpendicular things like this. Okay. And like this. These are perpendiculars drawn to the opposite side. And they are BE, sorry, and they are BE and CF. So let me mark it. So this is BE and this is CF. Okay. Now let's read the statement again. So BE and CF, so this is BE and CF are two equal altitudes. Okay, this is again a very key information. They are equal altitudes. So I'm just going to note it down straight away. That first thing is BE is equal to CF. Okay, they are equal altitudes of the triangle ABC. Now using RHS congruence rule, prove that the triangle ABC is isosceles. So a very straightforward hint is given to us that we have to use RHS congruence of triangles. Okay, because this is right angle, so we can use RHS congruence. So let's come here. Now focus on this triangle. So I'm going to use highlighter. This triangle CFB. Okay, it's a right angle triangle, and another triangle is BEC. Okay, this is also right angle triangle. Why it's right angle triangle? Because these are altitudes with 90 degree. So I'm going to straight away write it like this. In right angle triangles, so in right angled triangles, okay, which are these triangles? Triangle BFC and triangle CEB. Okay, so the first point is now if you, so once again let me erase this highlighted thing so the confusion is reduced. Okay, so if you look at the right angle triangle BFC, this right angle triangle BFC, what is the hypotenuse? The hypotenuse is the side opposite to 90 degree, so it's BC. And similarly for triangle BEC, the hypotenuse is hypotenuse opposite to right angle triangle, which is also BC. So and it's a common side, so I'm just going to say hypotenuse BC is equal to hypotenuse BC. Okay, because they are the same hypotenuse of the two different right angle triangles. Okay, so hypotenuse is equal to hypotenuse, that becomes our first point. And then the second point is side so side BE is equal to FC, or I'm going to say side FC is equal to side BE. Okay, why? Because that is given to us. Here it is. BE is equal to CF. Okay, BE is equal to CF. So I'm just going to use a highlighter. This is our side FC, which is equal to side BE or EB. So now thus, it's a right angle triangle. That's a key information. These two triangles are right angle triangles. Hypotenuse is equal to each other and one side is equal to each other. So thus, by using RHS test, okay. So let's okay. So I'm just going to write it down. By RHS congruence test, RHS congruence test, we say that triangle BFC is congruent to triangle CEF. Sorry, CEB. These two triangles are congruent to each other. That means, okay, if the two triangles are congruent to each other, that means angle CBF is equal to angle, so we went CBF is equal to angle BCE. Okay, so one to one correspondence is very important. I want to use a highlighter to note down these angles. This angle, okay, this angle is equal to this angle. Okay, CBF, so CBF is equal to BCE. Okay, so this angle. So these two angles are equal to each other because they are corresponding angles of the congruent triangles. So, and that is in fact the definition of an isosceles triangle. Okay, so in an isosceles triangle, the two angles are equal to each other. So by this definition, or I'm just going to say here, so from this, we can say that the bigger triangle, okay, that is triangle ABC, is an isosceles triangle. Okay, and this is exactly what the question had asked us to prove, that using RHS congruence rule, prove that the triangle ABC, let me try to zoom in, the triangle ABC is isosceles. So in this triangle ABC, in order to prove its isosceles, we have proven that these two angles are equal to each other. That's all.